Good morning, class 10. Welcome in this math period for real numbers. I am once again reminding you, in real number chapter, Euclid division lemma has been removed by CBSE. So you will avoid exercise 1.1. And you have to solve question of 1.2, 1.3 and 1.4. Although I have explained what is fundamental theorem of arithmetic, once again I remind you and I try to solve some question. Every composite number can be expressed as product of prime numbers. This is called fundamental theorem of arithmetic. By this theorem, you will learn how to find HCF and how to find LCM of the given numbers. Euclid division lemma, you forget this theorem. Now you see question of 140 is a composite number you express in the product of primes. Very simple. You find the prime factor of 140 and you will write like this. So this will be question number 1. So all the numbers, these numbers are 5 prime numbers. So this will be 2 into 2 into 5 into 7. This is only solution to question number 1. So express all the given numbers in the product of primes. So 140, and similarly you will solve the other question. Now you see 26 and 91. These are the numbers. And you have to find the HCF and LCM, and you have to use that. You have to verify that rule. HCF into LCM is equal to product of two numbers. This is only true for only two numbers. Not more than 2. So this rule is applicable for only 2 numbers. So you have to find the HCF, also you have to find the LCM and verify this rule, HCF into LCM. So you find the prime factor of 26, so you will get 2 into 13. 91, you find the prime factor as, you will get 7 into 11. Now you see 7 into 30, 7 into 30. So these are the prime factors of these two given numbers. With the help of these two prime factors, you find the LCM. LCM, we take all the prime factors with maximum power. 2 only 1, 7 only 1, and 13 only 1. And you will multiply, you will get the LCM of the given number. 34, 52, 2, and 180. This is the LCM. So how will you find? You find the prime factors of given numbers and you take all the factors with maximum power. And you multiply all these, you will get the LCM. Now come for HCF. HCF, the common factor with minimum power. What is common? 13, and minimum power is 1. So HCF is 13. LCM and LCM. And now you verify this rule. HCF into LCM is equal to product of two numbers. This is the rule. And once again I remind you, this is true for only two numbers. Product of numbers, two numbers. So HCF is 13, LCM 182, and numbers are 26 and 91. You multiply 13 to the 26, carry over 2. 13 is 104 into 166. Carry over 10, 713 or 10, 22. You multiply 26 into 20, 91. 6, 2, 9, 6 are 14, 9, 6 are 54, 5, 9 2 are 18, and 5, 23. 6, 6, 2, 3. So here is also 2, 3, 6, 6. This is verification of this question. So in question number 2, you have to find the HCF and LCM by prime factorization, and then you have to, second part, you have to verify this rule, HCF into LCM. Here we observe the product of HCF and LCM 2366, and product of numbers is also 2366. So this is the verification. Now you see question number 3. What is question number 3? Find the HCF and LCM by prime factorization. I have already solved, so no need to solve again. So you find the HCF and LCM by the prime factorization. Don't use the Euclid division lemma because it has been removed from the syllabus for the coming examination. Now you see HCF of this is 9. Or find the LCM of these two numbers. So you solve by that rule. HCF into LCM is equal to first number into second number. HCF is given 9. LCM you have to find. Numbers are 306. This is also method to give the number, and 657. Now very simple, LCM is equal to 306 into 657 upon 9. You cancel 9 3 are 27, 3 9 4 you multiply 34 into 657. You will get the answer. So you will multiply. So this is question number 4. Now is it question number 5. 6 power n. Question is, 6 power n can end with the digit 0. My dear students, 0 should be in the unit place. So what is the condition? Condition is for 0 in one's place, one factor should be 5. One factor should be 5. Should be 5. Because if you want to multiply 5 by 4, 5 by 2, one factor should be 5, other factor maybe should be 2. So this means, you see the question, 6 means 2 into 3 power n. So what is the factors of 6? Factors of 6, 2 and 3. And we have no 5 in this factor. And so it cannot end with the digit 0. This is the technique in this question, in this type of question. It cannot end with the digit 0. So this is question number 5. So for 0 in the ones place, the factor should be 5. And here no factor of 6, we are not having 5, therefore it cannot end with the digit 0. Now you see these two numbers, verify these are composite numbers. Definition, composite number should be in the product of primes. Now here we see one sign is plus. So how can you prove that? So for proving a number composite, you know very well, there should be written in the product of primes. So now you see 13, you take the common 13, and here you will get 7 into 11, a plus 1. Now 13, and this will be 11, 7, 77, a plus 1. You are getting 13 into 78. 13 is already prime number, 78. You find the prime factor, 2, 39, 3, 13. So this number given question can be written like this, 2 into 3 into 13. What do you see? We see these numbers given in the question can be written in the product of primes, and therefore this is composite number. Understand? So now you see here one sign is plus. So you have to change into. So how will you solve? Either you multiply these 3 and you add 13 and you find the prime factor. Better you take the common. Similarly, you take 5 common here. 5, you will take the common, and here inside the bracket you will get 7 into 6 into 4 into 3 into 2 into 1, or, and this will be 5 common and this will be plus 1. So इस तरह से इसको हम बना सकते हैं. So this is question number. All the questions I have explained and you will solve. One question you see, how will you find without actual division that will terminate? The decimal representation will be terminating or non-terminating. So 1.4 question number 1. 30 upon 3 to 5. और इसमें और भी क्वेश्चन है कि if this is a terminating, you convert into decimal. First you find the prime factorization of the numerator. 3, 1, 2, 5, you divide by 5, 5, 6, 8. So you will find the prime factor in the rough, and then you will get the prime factorization of the numerator. So the numerator of 3, 1, 2, 5, 5 into 5 into 5 into 5 into 5. So 13 upon 5 power 5. I have already explained that the rational numbers, if it represents terminating decimal, the denominator should be either in this form 2 power n or 5 power n, where n and n are non-zero integers. It means this is a terminating decimal. If I ask you why, because the prime factorization of denominator in the power of 5 power n, terminating decimal. And if it is terminating, you change into decimal. How will you change into decimal? So now you can see, for decimal, there should be product in power of 10. So 5 power 5, and if you multiply by 2 power 5, so this will be how much? 10 power 5. And you also multiply 2 power 5 in the numerator, 2 power 5. Now you see 13 into 2 into 2, 4 to the 8 to the 16 to the 32. 32, 2 to the 4 to the 8, 16, 32. And this will be 10 power 5. Now you multiply 13 to the 26, carry over 2, 30 to the 39 and 2, 41, like this, 10 power 5. So we are watching here, for finding it is terminating decimal or non-terminating, you found the prime factorization and denominator. And now, if the denominator is factored like this, 2 power n or 5 power n, this will be terminating decimal. And if it is terminating, it is given in the question, you find in the decimal. Decimal, you know very well in lower classes you have learned, you divide the numerator by denominator. But one easy method, you convert the denominator in power of 10. So that will be easy. So 5 into 5 into 5 into 5. So for getting in power of 10, it is very clear you multiply by 2 into 2 into 2 into 2 into 2. So that means 2 power 5, you multiply the denominator. But at the same time, you have to also multiply the numerator by 2 power 5. So you multiply numerator and here is power is 5. So this will be how much decimal? 6, 1, 4. 5 power 1, 2, 3, 4, 5. That's decimal. तो इस तरह से इसको क्वेश्चन नंबर 1.4 में है कि विदाउट एक्चुअल डिवाइडिंग हाउ विल यू फाइंड इट विल टर्मिनेटिंग डेसिमल और नॉन टर्मिनेटिंग रिपीटिंग डेसिमल. If the prime factorization of denominator 2 power n, 5 power n, it will be terminating, otherwise no. And if it is terminating, you convert into decimal. So first portion is completed, terminating decimal, and now you have to change into decimal. So for changing the given rational number into decimal, you have to obtain the denominator in power of 10. So we are getting 5 power 5. So you will multiply 2 by 2 power 5. So you will get 10 power 5. 10 power 5 means 5 0 after 1. And you multiply 2 power 5. And now you see this will be the decimal. And if you want to verify, so you can verify by dividing. So no need. This is the rule. This is in question number 1.4. So, my dear students, I want to wrap up this topic. First, you have learned how will you find HCF and LCM, and how will you verify the product of two numbers is always equal to the product of their HCF and LCM. Many examples you can verify. And second, you have learned without actual dividing, how will you find a rational number is terminating or non-terminating repeating. 2 power n or 5 power n is the prime factorization of the numerator in this form. That will be terminating, otherwise no. Or if it is terminating, you change into decimal. This is question number 1 and many questions in question number 1. So that's all. This is the end of this chapter. Understand? So we will solve and I will try to solve it. Thank you and have a nice day.